8.2 is all about dividing monomials. We're going to split 8.2 into two sections, dividing with positive exponents, and then 8.2b would be negative exponents. So we'll get to that in the next video if you need to fast forward or move on to that one instead. So the first question says, what happens to exponents of like bases when you multiply, like x to the second times x to the fifth? Well, of course, we will add the exponents. So what do you think would happen if we divide? We do the exact opposite. We're going to subtract them. So in division, you're actually subtracting the exponents, which is opposite of multiplication, of course. So let's see what happens. We're going to do one the long way so that you can understand why this is happening, and then we'll take the shortcuts. So 4 to the fifth would be 4 times 4 times 4 times 4 times 4. Just write it out 5 times. And 4 to the second is 4 times 4. And we want to simplify this, so the best way to do this would be to cancel 2 on the top with the 2 on the bottom. And what does that leave us with? It just leaves us with 3 on the top. So that would be 4 to the third over 1, because nothing would be left on the bottom. Or you can just write 4 to the third, which is easier. Okay? So this is why we're subtracting, because when we're dividing, we'll end up canceling some of the like terms, and by canceling them, I mean by taking them away. Okay? So the first division rule is when dividing two powers with like bases, you subtract the exponents. Okay? And so we're looking at this. The first example is 3 to the 6 over 3 to the second. 6 minus 2 is 4, so we're left with 3 to the fourth power. This one, a to the fifth and a to the fourth. 5 minus 1 is a to the first. All you do is subtract the exponents. Now in 3, a little different. 2 minus 2 would leave none behind, so they just cancel out. They're gone. And then y to the sixth and y to the third will leave 3 behind there. 4 has one small difference. Let's talk about the variables first. There's multiple variables here, so you just look at each one individually. Remember, if it doesn't have an exponent, it's understood to be a 1. So m to the 4 minus 1 would be 3. N to the 7 minus 5 would be 2. P to the 10 minus 8 would be 2. That's it. Now, you have to be careful that you don't apply your exponent rules to coefficients. So this is not 12 minus 4 gives us 8. Think back. If I gave you this problem, 12 over 4, and I said simplify that, what would you get? You would certainly not get 8. You want to make sure that you always look at the coefficients using all the rules that we've always used. This is just a fraction that needs to be simplified. So 12 divided by 4 would give you 3. So be very careful that all these rules that we're talking about are dealing with exponents and not with coefficients, unless they have exponents on them. All right? What if there are more of one base on the bottom? So in all of these, there were more on the top. So this is what happened. But look at this example. What if there's more on the bottom instead? So let's go the long way again. 2 to the third, we would just expand that. And 2 to the seventh on the bottom. So we're going to cancel just like we did those other ones. But now we'd have 1 left over on the top because they're all gone, and 2 to the fourth left over on the bottom. So the rule of thumb is you're going to multiply them, but any of the leftovers would be left wherever there were more. So this is the rule we're amending. Division rule number 1. When dividing two powers with like bases, subtract the exponents and put the leftover wherever there was more originally. So the leftover is always going to be where there's extra. Okay? In this case, it was on the top, so it ends up on the top. In this case, it's on the bottom, so it's left on the bottom. What we do not want to do is get negative exponents. We will spend the whole next lesson learning how to get rid of the negative exponents. So we don't want to be creating negative exponents. So a couple minor rules before we move on. A to the 0 power, anything to the 0 power is always equal to 1. And that's anything to the 0 power is 1. So if I drew a little person and I raised them to the 0 power, that would be equal to 1. Okay. We can talk more about why that happens, but you want to make sure that you understand that. So you want to be careful that you always leave the leftovers wherever there are more. So let's go through these. X to the 20th and x to the 12th. We still subtract. Big minus little leaves 8 behind, and I say, are the leftover on the top or the bottom? There were more on the bottom, so that x to the 8th is left on the bottom. And you have to be careful that your reader knows that it's left on the bottom by leaving a 1 on the top. Otherwise, you don't know if that's the top or the bottom. Okay. Here, I say draw your fraction bar, and then just start going through the variables. X to the 5th, x to the 2nd. 5 minus 2 is 3. But there were more on the top, so the x to the 3rd belongs on the top. Y to the 10th, y to the 7th, there's more on the bottom. So 10 minus 7 is going to give us 3 again, but this time those 3 are left on the bottom because there were more there. And then the z is just a loner. He doesn't simplify with anyone, he just stays right where he was at. That's it. 7, draw your fraction bar. Start with your coefficients. Now this is the same base, so we can use exponent rules. You don't need to expand this. So this is 3 to the 3rd, and this is 3 to the 1st. 3 minus 1 gives me 2 left over on the top because there were more on the top. M to the 5th over m to the 5th. 5 minus 5 would be 0. That just drops out completely. N to the 7th and n to the 3rd. 7 minus 3 is 4. And those 4 leftovers will be on the top because there were more on the top originally. P to the 12th and P to the 10th. 12 minus 10 gives me 2 leftover on the bottom because there were more on the bottom. Why don't you try these other two? Go ahead and push pause, see if you can do them, and then come back and watch it. All right, so let's talk variables first because that's easiest. You should have x to the 5th on the bottom. The y's cancel, and z to the 7th on the top. Remember, that's understood to be an exponent of 1. For these guys, maybe it's good to just put a box around it and then look at it like a fraction. That's all it is. What is negative 6 over 2? That would be negative 3. One of the flaws, misconceptions here, is that if it's a negative at all, well, we'll talk about negative exponents tomorrow, but for now, what you want to make sure you understand is that's just a fraction. Just simplify the fraction. That's all. And if you put a 1 on the bottom, that would be fine too.
Dave Ash, please dial 5187. 5187.
All right, in this one, variables first. A to the 8th, left over on the bottom, 10 minus 2. B to the 13th, left over on the top, bottom as well. Now, c to the 0, anything to the 0 power is equal to 1. So if I get rid of this and write times 1 instead, then that would just be 24 times 1, which is still the same thing. So anything to the 0 power, you can actually just get rid of. Boom, it's gone. And so then we have a 24 over 18 left over. Remember, that's just a fraction that needs to be reduced. This time, we can't divide the top and bottom by 18 because that won't work. So we find the largest number we can divide them by. So they both divide by 6. 24 divided by 6 is 4. 18 divided by 6 is 3. So always look at those fractions and say to yourself, I just need to simplify that fraction, however that needs to be done. Okay?
Dave Ash, please dial 5187. Dave Ash, 5187.
How about this? How would you do this? A fraction raised to an exponent. So let's do it the long way. 2/3 to the 3rd power is really 2/3 times 2/3 times 2/3. And if we simplify that, 2 times 2 times 2 is 2 to the 3rd power. And 3 times 3 times 3 is 3 to the 3rd power. So how can we have skipped that expansion step and gone straight to this? All we're really doing is distributing that exponent to the top and distributing it to the bottom. So it's now 2 to the third over 3 to the third, and that's it. So the second division rule, when raising a quotient remember is a fraction or a division, to a power, which is an exponent. Okay, so you're basically, it's saying when you're raising a fraction to an exponent, then you're going to distribute the exponent to the numerator, that's the top, and the denominator. Okay, just pass it out. 2 to the third, 3 to the third. Boom, done. Very simple. Okay. So let's try some of these. These look crazy. Very simple. Very simple. So don't get all worked up about it. Okay, take that 4, pass it out. 2 to the 4th, p to the 8th, 3 to the 4th. Okay. So as you're distributing, you're still following the same rule we had before, which was multiplying. You're just doing it on the top and on the bottom. Now, it is possible sometimes these fractions will reduce. So you may need to expand them. And if you're ever confused, just always expand them. 2 to the 4th gives us 16. And 3 to the 4th gives me 81. So if you are ever confused, just expand both of them and then check if you can simplify. But here's the rule of thumb. I know 2 and 3 have no factors in common. If I listed out all the factors of 2 and all the factors of 3, we would not be able to simplify that, okay? Which means if I expand the factors of 2 and expand the factors of 3, I won't be able to simplify those numbers either. So this would have been fine, or this. Either one is fine. Now let me show you an exception to that. Let's go ahead and distribute that 2. So we get 3 to the 4th, m to the 8th over 9 to the 2nd. Now I know that 3 and 9 share some common factors. They're both divisible by 3. So that means that they will simplify if I expand them. So we must expand them on this one. 3 to the 4th is 81. And 9 to the 2nd is also 81. So those will actually just cancel and we get m to the 8th. So we want to give the most simplified answer we possibly can. And so if you notice that they are both divisible by the same number, then that means you're going to need to expand them and simplify it. In this case, either one is fine because they're both technically simplified. So in 13, I know right away that 2 and 4, those are my two coefficient bases, have some multiples in common because 2 goes into 4. So instead of going to this step where I write it in exponent form and then expanding it, if I know that these bases have common factors, like 2, I'm just going to expand it from the beginning. So this becomes 2 to the 6th power. 3 times 2 is 6. 2 to the 6th power is 64. So I'm saving myself a step. You can take 2 steps if you'd like we did here. Or you can take the shortcut. So this becomes a to the 15th and b to the 3rd. On the bottom then we get 4 to the 3rd, which is also 64. And c to the 0 times 3 is still going to be 0. So remember I said anything to the 0 power, you can just drop it out. It's gone. Pretend it's not even there. So nothing's left over on the bottom. And then all we do is cancel the 64s, and we're left with a to the 15th, b to the 3rd. Go ahead and try these on your own. I think that you should be okay. 14 is just like this one. The rest of these are all mixed rules. Maybe I'll do one with you. Let's do 17. No, let's do 19 because that seems to be the hardest one. So you want to start with your exponents on the outside first. And so we distribute it. We get 3 to the 6th, m to the 8th, p to the 36th. Over, we got a 3 down here, 3 to the 6th, m to the 9th, p to the 0, and r to the 21st. Now p to the 0, again, you can just get rid of it. It's equal to 1, so it's not going to change the fraction at all. The 3 to the 6 over the 3 to the 6, cancel. We've got 9 and 8, so 9 minus 8 is 1. That leaves 1 on the bottom because there were more on the bottom. P to the 36 just stays because it's not going to simplify with this guy anyways because he's gone. And then r to the 21st on the bottom. Okay? You go ahead and try the rest of these on your own and see how you do.